Hello, I am IPSITA Ghosh. I am the Assistant Professor of Swami Vivekananda Institute of Science and Technology. And today I am going to discuss on the topic of basic operations on signal. So in the previous lecture I am discussing about the introduction to the signal. And the signal may be a function of time, temperature, position, pressure, distance, etc. And some signals in our daily life are music, speech, picture and video signal. So systematically, if we can define a signal, it is as a function of one or more independent variable which contains some information is called a signal. Because it is independent variable, because it is the function of some variable which is time, temperature, etc. So here I am discussing about the basic operations on signal, and which is basically two types: operations performed on independent variable of the signal and operations performed on amplitude of the signal. So first I am discussing about operations performed on independent variable of the signal. So here the independent variable of the signals means time, because the normally all functions are basically dependent on time in the signal system topic. So first I am discussing about time scaling. There are different another properties like time folding, time delay or advancing. So here I am concentrated on time scaling. Here I am taking one signal yt equal to xat, where yt is a variable which is taking equal to xat, where a is one value, and depending on that value the signal will be compressed or expanded. So if I am taking a is greater than one value, the signal will be compressed in time. And if I am taking the value of a in between 0 to 1, the signal will be expanded in time. So in that case, first I am saying if I am taking a is greater than 1, signal will be compressed in time. I am taking the value greater than 1, but the signal will be compressed in time. So what is the matter? Suppose I am taking figure A. Here I am showing one signal xt, that is range from -1 to 1. Okay, so first I am telling that in the x-axis it is a time axis, and in the y-axis it is amplitude axis. So in case of time scale, xt has a value from -1 to +1, and in the amplitude scale xt has a value of 0 to 1. Now in that case, if a is greater than 1, as I am showing that a is multiplied with the time axis, so the time axis getting double if a is taking equal to 2. So the signal is yt equal to x2t. That means 2 is multiplied with the time axis. That means the time scale is getting double. If the time scale is getting double, that means time scale is stretched from -2 to +2. And previously it is from -1 to +1. So now if x2t is figured out, then it is showing that it is from -2 to +2. So the time scale is from -2 to +2, but the signal width is as it is from the previous one by as the previous one. In that case, time scale is getting double, but the signal width is same. And if the signal width is same, so the signal looks like a compressed signal, and it is from -half to +half. But in the amplitude scale domain, it is from 0 to 1, and in that case in the figure V also it is from 0 to 1. Now in the third figure, that is figure C, I am taking yt equal to x half t. That means I am taking the values in the range of 0 to 1. 0 in between 0 to 1 I am taking half. So the signal will be expanded in time as shown in figure. So in that case, half will be multiplied with the time scale. That means time scale is getting compressed. And if the time scale is getting compressed, then the signal looks like expanded signal as seen in the figure, and it is range from -2 to +2. But the amplitude scale is from 0 to 1 as it is. So it is our time scaling operation, where depending on the values of a, the signal will be compressed in time and the signal will be expanded in time. So now we are going to the next part, that is time shifting. So in case of time shifting, I am taking yt equal to x within bracket t minus t0, x within bracket t minus t0. Time shifting operation is also known as time delay or advancing according to the operation. So first I am taking delayed signal. If t0 is greater than 0, suppose I am taking t0 is greater than 0 value like 1 or 2. So then the signal is yt equal to x t minus 1 or x t minus 2. So in that case, I am telling that the function is a delayed signal because the whole signal is shifted to the right side. The whole signal is shifted to the right side. That means the signal start from, previously the signal start from 0 value. Suppose it is started from 0. First the signal is started from 0 value. Now if I am taking yt equal to x t minus 2, then the signal is started from positive value, positive 2 value. So previously signal started from 0 value and now the signal is started from 2 value. That means it is delayed by 2 value in the right side. So if t naught is greater than 0 value, I am telling that the function is delayed. And the next case, if t0 has the lesser value, if t0 has the lesser value, in that case, suppose the signal is start from 0 value and I am taking t0 equal to minus 1. So the signal is yt equal to x t minus of minus 1. That means it is x t plus 1. So previously signal is start from original value 0 value and now the signal is start from minus 1. That means it is going to the negative axis. The signal start from minus 1. So it advances. Previously it start from 0 value but now it is start from minus 1 value. So the time advanced. So the function is a advanced function if it is shifted in the left side. So if t0 has greater than 0 value, then it is delayed signal, and if t0 is lesser value, then it is a advanced signal. In the following figure A, here I am showing one signal xt which is from minus half to plus half and the amplitude is from 0 to 1. So here the signal is started from minus half and ending with plus half. Now I am telling if the t0 has the greater than 0 value, it is a delayed signal. Here I am taking t0 is equal to 2. That means t0 has greater value. So it is also a delayed signal. So why it is a delayed signal? In that case, the signal start from minus half value. But in case of yt equal to x t minus 2, the signal is shifted to the right side by 2 unit. In case of t0 is greater than 0, then the signal is shifted to the right side. So if it is shifted from minus half, then minus half to plus half and plus half to 3 by 2. So it is shifted by 2 unit in the right side. So now in figure B, it is started from 3 by 2 and ending with 5 by 2. The signal width is same, minus half to plus half, it is 1, and in that case also 3 by 2 to 5 by 2. So it is also 1. Signal width is same, but the signal start from 3 by 2 to 5 by 2. So it is previously it is started from minus half and now it is started from 3 by 2. So the signal is delayed signal because it started after the previous one time. So it is a delayed signal. Similarly, the advanced signal also done. Okay, now I am going to the next topic, that is time folding. So here I am taking yt equal to x of minus t. So let us consider one continuous time signal xt. Now it is folded with respect to the time axis. Now what does it mean, folded with respect to the time axis? With respect to origin, it is folded. With respect to origin, it is folded, or mirror image, or sidewise displacement. With respect to origin value, it is changes. In figure A, the xt started from minus t1 to t2. And in figure B, yt equal to x of minus t. So the origin, with respect to origin, it is rotated. With respect to origin or about the origin, it is rotated. So t by 2 is going to t1 and minus t1 is going to minus t2. The whole signal width is same. But the time scale is from minus t1 to t2, and in that case time scale is from minus t2 to t1. Okay. Next, the operation performed on the amplitude of the scale. So previously that is on the basis of the time scale. Now it is on the basis of amplitude scale. So here different kind of operation: amplitude scaling, addition, multiplication, division, differentiation and integration. In case of amplitude scaling, the amplitude of the signal can be changed with amplitude scaling. Suppose I am taking yt equal to cxt and c has the value suppose 2, 3, 4, any value. So suppose I am taking yt equal to 2xt. That means the whole signal xt is multiplied with a value 2. But 2 is multiplied with the amplitude part of the xt. In the previous one, in case of time scaling, I multiplied the value with t, x of 2t, where 2 is multiplied with the t value. But in that case, yt is equal to 2xt. Here 2 is not multiplied with the time scale. It is multiplied with the amplitude scale. That means in that case, the amplitude scale will vary, not the time scale. In the previous case, I am telling it is operated on the time scale. That's why time scale is getting stretched or compressed or folded or anything. But in that case, time scale is unaffected and the 2 is multiplied with the previous value 2xt. That means xt means we are telling 1 into xt. In that case, I am telling 2xt. That means the whole amplitude is multiplied with a 2 value. Suppose xt has amplitude from 0 to 1, and if we multiply it with a 2, then it is from 0 to 2. That is our amplitude scaling. And here I am showing the whole concentration on the continuous time signal. It is same also in discrete time signal. I am telling yt equal to cxt. It is same for yn equal to cxn. So that is in the discrete time domain. So same operations is done on the discrete time domain also. So that is your amplitude scaling operation. Next, addition. In case of addition, at least we need 2 signal for addition. At least we need, suppose I am telling 2 plus 3. So at least we need 2 value. That is 1 2 and 1 is 3. So in that case also, if we are going to add 2 signals, so that means at least we need 2 signal or 2 or more signal. So yt equal to x1t and x2t. Here I am taking x1t and one continuous time signal and x2t another continuous time signal. So it is x1t plus x2t. It may be subtracted. So then the signal is yt equal to x1t minus x2t. So that is in the continuous time domain. The same thing is done on the discrete time domain also. That means here then the example is yn equal to x1n plus x2n. x1 is n is one signal and x2n is another signal. Okay. Next one is multiplication. In that case also we need 2 signal. One is x1t, another is x2t. So yt equal to x1t into x2t. And in case of discrete time domain, it is also yn equal to x1n into x2n. So it may be divided also. So then yt equal to x1t divided by x2t. Similarly, let x1n and x2n be two discrete time signal, and they similarly divided yn equal to x1n divided by x2n. Next, I am going to the property differentiation and integration. Suppose we are taking xt be a continuous time signal and it is differentiate with respect to time. Yt equal to ddt of xt. So here yt is the derivative of xt. It may be a derivative of other function if x is dependent on other function. Suppose x is dependent on some other parameter like temperature, then it is yt or y temperature is the derivative of that function. And the last one is integration. In case of integration, yt is equal to minus infinity to t, integrate over minus infinity to t x tau d tau. So this is our basic operations of that is performed on amplitude of the signal, and previously I am showing the time scale of the signal. Okay, thank you.